So we're continuing 7.1, and I've in the previous video talked about how this number up here is called the index. So the index is 4. So basically what this boils down to is you're looking for what number times itself 4 times would give you 10,000. And I do want to point out that your calculator will do this as well. Let me pull that up. So you go under the math tool, and this time you just go to the X option, and then you'll have a blank to put the 4th root of 10,000. And you'll get exactly 10. Now I do want to point out, so this answer is 10 if you're using a calculator, but I do want to point out that you could do a factor tree down like 2 and 5,000, and then 2 and 2,500. Let's see, 2 and what would that be? 1, 2, 5, 0, and then 2 and I'm drawing a blank. Let me pull up that calculator again. Oops. So you could do that 10,000 divided by 2, divided by 2, divided by 2, divided by 2, 625. There we go. Well, now it's no longer divisible by 2, so I can start dividing by 5. So 5 and 125. Now I can do the rest on my own. 5 and 25. And then 5 and 5. And if the index is 4, you want a group of 4 of the same. So there's 4 2s, write that once. And then there's 4 5s at the bottom of the tree, so you write that once. And lo and behold, 2 times 5 is 10. That's how you can do it by hand. Now the next one is kind of okay. The main thing I want to get at is if you have an even index, we can only do an even index of a positive. Because if it's even, that means that every negative, like it has to repeat itself. So I'm going to jump ahead to this example right here. Because it's an even index for a negative number, this is impossible. And you can check that with a calculator. If I were to do the 4th root of negative 625, my calculator tells me that there's a non-real answer. It is not possible to get a real answer there. But you can do an odd index of any number. I'll just put any, I'll put real number, because positive or negative. Because the whole premise is that we want what number times itself. We have 5 negative 1s. And the reason why this works is, so 2 negatives will make a positive, and then these 2 negatives will make a positive, and then we still have 1 negative left, which is why we can do an odd index for all positives and negatives. But anyway, the answer to this one would be negative 1. Put a little box around that. This one, we're just doing the square root. If there's no index there, it's implied to be the square root. The square root of 81, we already talked about, is 9. That negative stays with the problem. And then this one, just make sure you do each cube root individually. So you can break down 27. And we want a group of 3, because it's a cube root. So we're looking at 3. And the fastest way of doing this is understanding that you divide by the index. 9 divided by 3 is 3. The other way I've taught it is by writing out 9 x's. And every group of 3 gets written in front. So there's 1, 2, 3 groups of 3, so it becomes x to the 3rd. So moving on, pretty important stuff here. If the index is even, then what happens is that the answer is the positive version, the absolute value of that a value, whereas if n is odd, it's the same value. And the main reason for that, imagine for a second that maybe we're doing the square root of negative 2 squared. Well, what happens is you're going to square the negative 2 first, and you'll get positive 4, and then the square root of 4 is 2. So you can see how that, because that base was negative, then it's going to give us a positive answer anyway. So the whole reason for explaining it that way is for you to understand that the answer to this one is positive 4. And you can work it out if you'd like to. This one, again, I'm going to explain it the way I just did the previous one. The fastest is understanding that you divide by your index. So this answer is going to be x to the 7th. 14 divided by 2 is 7. This one, same premise, is and I think the book, now that I'm thinking about it, because they want you to get practice with, is it the positive version or is it the negative version? I think the book, actually now I'm thinking about, puts absolute value here. I'm not so worried about that. I'll accept either answer. Same thing with this one. I believe I would accept if you just wrote x plus 7, but I believe the book goes ahead and writes the absolute value of x plus 7 because the n is even here. Whereas this one, the answer is just negative 7. And I can work it out because if you were to do negative 7 to the 3rd power, you get negative 343. Let me double check with that calculator. Where's my calculator at? There it is. Negative 7 to the 3rd power, negative 343, and then hit the math button to do the cube root of, if I just type in second answer, second negative gives me that answer, and you get negative 7. So you can work it out that way if you'd like to as well. But a few more, maybe slightly more complicated problems. The index is even, so that's fine if you go ahead and put the absolute value. I'm not going to concern myself with that, though. The square root of 49 is 7, and the square root of x squared is x. So if you just write 7x, you'll get full credit, but if you put absolute value, I believe that's what the book wants. Whereas this one, because the index is odd, they don't have the absolute value, so just leave it as 3x minus 5. Now you have to do a little bit more work here with the last exercise, and the reason why we have it is we have the square root, is if you notice this is factorable, of x plus 8, x plus 8. So we write x plus 8 squared, and then the square root and the square will cancel, but because it's an even index, I believe the book wants you to write it as the absolute value. I will forgive you points if you do not write the absolute value on these. Notice I didn't write the absolute value on this one because 4 is positive, so saying absolute value of 4 is kind of redundant. So just giving that to you. As we move to exercise 6, we're finding the value of each function. So it's just function notation, getting you to remember that x is 8. So if I plug in 8 here, 8 minus 4 is 4. So this is equal to the square root of 4, which is 2. There you go. Now, I'm fine if you leave your answer in simplest radical form. So if you plug in 6 in here, and you wrote this 6 minus 4 is 2, so it's the square root of 2. But if you want to practice with your calculator, by all means you can. You know, square root of 2, 1.414. 1.414. Now looking at the next one, we're doing g of negative 1, so plugging in negative 1 in for x. So negative 1 plus 2 is positive 1, so we're doing the cube root of positive 1, which I would anticipate you knowing at this point is equal to 1. Whereas on this one, we're plugging 1 in for x. 1 plus 2 is 3, so we're doing the cube root of 3. This is the best answer in simplest radical form. However, if you want to, you can take it a step further by using your calculator. So I'll be fine if you actually figure out the decimal approximation, about 1.442. Now here's the thing, is we're moving on to domain and graphing, which I know you did in Algebra 2, at least the graphing part, because you may remember from Algebra 2 that the square root function, this is, I'm showing you the parent function of the square root. It starts at the origin and goes up and to the right like this. And if you don't believe me, you can use your graphing calculator, or you can use a table. You can make a T-chart and come up with these points. And so what you probably remember from Algebra 2 is when you're adding inside of the radical, this is a shift. Now, you might remember, you might not, so I'm going to tell you, if you add inside, we shift left 2 units. So instead of starting at the origin, we're going to start left 2, and then we have that behavior up and to the right. So this is the graph of that function. This is h. And that might help you understand the domain, because we read the domain left to right. So the domain starts when we get to -2 and goes infinitely to the right. Now maybe that method does not work for you. And remember, we just do infinity. What you could also do, if this is confusing, is you can set an equation, because we can only square root positive numbers and 0. So what's inside the square root must be at least 0, and then solve for x by subtracting 2 over. So x must be greater than or equal to 0 minus 2 is -2, which is exactly what I wrote right here. And feel free to write down any questions you have and bring them to class. Hopefully I can answer them. The only difference with exercise 8 then is it's the cube root function. So let me show you the parent function of that. The parent function, again, starts at the origin, but we go up and to the right, similar to square root, but we can also cube root negative numbers. And I should probably make this a skinnier graph, because it is a narrower, it's like a flattened version of the square root, but if you want, you can Google or you can use a graphing calculator to verify that. So what kind of shift do we have going on? Well, notice that the cube root stops right here. So this is a shift down 4. So instead of starting at the origin, we have to shift our graph down 4. There we go. I'll make it narrower for you here. Flattened, so to speak. And you can double check that this is correct. This is your graph. You can double check that's correct using a graphing calculator. But I also want to point out that the domain is all reals. And you know I like my interval notation, so remember this is your interval notation for all reals. And the reason for that is because we can cube root positives and negatives. We go infinitely to the left and infinitely to the right. And really the cube roots are really easy because the domain is always all reals. You never have to do any arithmetic. And you should be ready to do your assignment. Notice I do want you to do all of 85 through 92. Okay, odds for these, all of those. So enjoy.